Question number 11 asks you to draw the structure of cysteine. So cysteine, this is two cysteines that have a disulfide bond between them. Well, it happens to be that your textbook shows you this at the bottom of figure 4-6 in your textbook. All right, so that's part of it. So that's the molecule cysteine. All right, so I'm going to draw a part of it here just for the sake of time. So here's our cysteine molecule, or at least part of it. All right, so it has the disulfide bond here. Now, for our glutathione molecule, I told you guys I don't want you to be able to draw the entire structure of glutathione. The things I want you to know about glutathione, just to review, I want you to know that it's a tripeptide, so it has 3 amino acids. And I want you to know what those amino acids are. All right, you can find this in your textbook. So it's glutamate, cysteine, and glycine. All right, so what I'm going to draw now is I'm just going to draw it as glutathione with a little SH group hanging off of it here. All right, so now we need to use 2 molecules of glutathione to reduce the cysteine. So anytime we're doing a disulfide reduction, we're going to be doing nucleophilic attacks. So using thiols, I should say. So SHs by themselves are not great nucleophiles, but we can make them into better nucleophiles by first deprotonating them. All right. So now the deprotonated glutathione will be an S-, which is a much better nucleophile, and this can now attack one of these 2 sulfurs here. All right, the other one. All right, so now the bond here. This sulfur here now has too many bonds, so it has to break one, and it'll break the disulfide bond, and we'll go ahead and protonate the other side. All right, so let's move down here. So what do we have right now? Oh, let me change just so we can keep everything straight. Up at the top here, instead of R, I'm going to have these labeled as cysteines here, and then I'll keep the same label down below. So, all right, so we have now our cysteine. One of them has a disulfide bond to our glutathione. All right, the other cysteine now has a free SH group on it. So we've released this cysteine from the disulfide bond now. All right, at this point, we need a second molecule of glutathione to come in. All right, now we're again going to use this one as our new nucleophile. So I'm going to add in a base here so that I can abstract a proton, making this a better nucleophile. Right, the remaining electrons are going to come attack the sulfur of glutathione, and then these electrons will come up here and grab a proton. All right, so when we're doing disulfide attacks, all right, the sulfur that we're attacking, the one that then gets attacked is going to be the one that ends up with the disulfide. All right, in the case down below here, all right, this case, we don't want to, if we attack the other sulfur, we just end up with now another disulfide between that cysteine and the new molecule of glutathione, and we'd end up releasing the first molecule of glutathione just as free glutathione. So we effectively would have done nothing chemistry-wise. We wouldn't have achieved any net reaction. All right, but by attacking the sulfur of the glutathione here, it's a part of the disulfide bond. Now we're transferring that disulfide to the 2 molecules of glutathione and liberating the other cysteine. All right, so step 3 here, or the final products, I should say. All right, we have 2 molecules of cysteine that are now free, and we now have a glutathione disulfide bond. right? And that is it for the mechanism for this particular reduction.